Hey guys, to those of you who haven't joined in since physics, realize I got a new mic. Woo! Or at least got it to work now. Okay, so we're going to solve a system of equations specifically with three variables using Gaussian elimination and row echelon form. Now that sounds complicated, so let's talk about it. We have a step program here. First step, 0th step, is to set up a matrix. What the heck is a matrix? So a matrix is a simple way to write a system of equations or coordinates in space. So for our instance, we have a three-dimensional matrix because we have three coordinates or three variables that we're dealing with. So we have our 3, 4, -1, 5, -2, 1, and 2, -2, 1. And if you'll notice, all I did was I took all of the coefficients of our equations and put them here into this big parenthesis set. Now I'm going to also put our variables in here, x, y, and z, and then equals to our ones that are equal to our numbers equal to here. So all this is our initial matrix, which is actually unhelpful to us for Gaussian elimination because hence why I put step 0. But I still want to describe what a matrix is so that way it'll make sense what I do when I set up an augmented matrix. So really a matrix is a shorthand way to write this whole thing up here using the coefficients of all of the different equations, the variables involved in the equation. So of course, instead, if this were ABC, we would have ABC here is equal to all the numbers that each equation are equal to. And then how you would then go back is then you would say something along the lines of 3 times x plus 4 times y minus z is equal to 8. And then you could also go 5 times x minus 2 times y plus z is equal to 4, and then you would keep going down the road for the final one, 2x minus 2y plus z is equal to 1. Also, I just heard my parents come home. I gotta shut the door before they make noise. Don't make noise, thank you. Okay. Now that we have this set, we can set up our augmented matrix. Our augmented matrix is going to look more simple than that. It's going to be this even simplified. So it's going to be this simplified to this. So we're going to have all of our coefficients again. And then we're going to have a line here that will represent the equal sign, and then all of our finals. So basically it's the same thing, but we don't mention all the variables used because it's kind of obvious which variables are used. And kind of because we know that this row represents x, this row represents y, this row represents z, we can kind of keep in the back of our minds that those are the rows that are involved. And then we don't even have to mention what variables are there. And we can instead use just this augmented matrix instead. So now our second step is kind of complicated. It says to modify the matrix by changing the rows, either by row addition, row multiplication, or both, to put the matrix in row echelon form. First of all, what's row echelon form? Row echelon form is making this number, and this number in that order equal to 0, and then this number, and this number equal to 1, although that is more of an optional step, which for this specific problem, because I've done it before to make sure that it works fine, is optional because it's just not as necessary. Although I'm sure there are times where it would be more helpful to put it in full row echelon form with those equal to 1. That would make more sense. So steps to do this would be turn this one to 0 first, this one to 0 second, this one to 0 third, and then an optional turn all the circled red ones to 1 fourth. So how exactly would we go about doing that? Row addition and multiplication. So we're going to do a very similar thing to what you would do with systems of equations when you only have 2 of them. So let's just say instead we have a theoretical 2x plus y is equal to 2, and then like x minus 2y is equal to, I don't know, like -4. And then you go about trying to solve this via elimination or something like that. You would then multiply this one by some constant to get the y's to cancel because they're opposite sides, the constant being probably 2. So I'm going to just say 2. And then you would add the 2 and be left with something x is equal to some other number. So really what you're doing is you're multiplying and adding, hence row multiplication and addition. So we're going to do a shorthand version of what I just did. So now what we're going to do is our first step. We're going to try to get this bottom number 2 to equal 0. So we're going to add this. She's calling me. I am in the middle of something. I'm in the middle of a video! Oh my god. So, what was I saying? Yes, we have row addition and multiplication. And I'm sure you guys heard that great because the microphone follows through. Now, what numbers could we multiply some of these rows by to get this number to equal 0 when we add them up? Well, we can say this row multiplied by -2. So we could go -2 row 1 plus 3 row 3. And that would get it to equal 0 if we added them up. And there's a reason why I've put this arrow here. This arrow specifies that we're only modifying this third row. Because when you do this addition here, you are only modifying the one row that you choose. The other ones stay the same. So we are going to leave these other ones how they are, and then only change that bottom row. So what exactly does this mean here? I'll just show you really quick because I'm sure it's confusing why I put those specific numbers. We have -2 times the first column of row 1, which for us here is a 3. We have then +3 times the first column of row 3, which is 2, which -2 times 3 plus 3 times 2 is equal to all 0, which is exactly what we wanted. We wanted that bottom one to equal 0 when you added them up. So now we'll do the same thing for all the other ones. -2, the next column over, which is 4, plus 3 times the next column over, which is -2. So that would be -8 plus -6, which is -14. We can erase this now. And then we go -2 times row, this third column, -1 plus 3 times 1. -2 times 1 is -2, plus 3 is 1. This is all equal to 1. And then we do the final one past the dash. We go -2 times 8 plus 3 times 1, because those are the rows in question. -16 plus 3 is -13. There we go. Now I'm going to move this because it's in the way. Now we have this bottom one equal to 0. Our next step, get that middle left one to equal 0. So now what we're going to do is we're going to use this top row because there's nothing we can multiply 0 by to get it to equal 5 or -5. And then multiply it by some constant to get it to equal some other constant multiplied by 5. So we're going to do the same thing. We're going to modify this middle row because that's the one we're searching for the 0 in. So we have to then multiply this by some constant, this by some constant by finding the least common multiple. We'll do -5 row 1 plus 3 row 2. And that would be our good one that we would use. Of course, because we're only modifying that second row, the other two rows, the top and bottom, stay constant. Now we can go and do the middle row. The middle row says -5 row 1 plus 3 row 2. Of course, that's going to be 0 because we said it would be 0. And the math all checked out for us using those specific constants. -5 row 2 is 4 plus 3 row 2, column 2 is that. So negative 20 plus negative 6 is negative 26. And then now we get negative 5, negative 1, plus 3 times 1. Negative 5 times negative 1 plus 3, negative 1 is 8. So now we get the final one, negative 5, 8 plus 3, 4. Negative 5 times 8 is negative 40 plus 12, which is negative 28. Okay. And now we can solve for this one, this number here, to get to equal 0. Really quickly, I'm just double checking that that negative 13 is indeed the number we're supposed to have. Negative 2, negative 16 plus 3, perfect. Okay. I've done this problem twice over in testing, making sure that it works, and I'm just making sure all the numbers are what they're supposed to be. I would love to do this problem again and record it again. That would be cool. Not doing that. So now this third one, we have a little bit of a restriction because we can't use this top row despite it being easier than the middle row to use to try to nullify, because if we were to multiply this one by something and then add it to the bottom one to get this one to equal 0, this 0 here would no longer equal 0 because it's being added by some number times 3. So we have to only use these two rows here to keep these two equal to 0. So we have to do something times row 2 plus something times row 3, and we can only do that. We can't use row 1. So I already went ahead and did this one like I already said, and I already determined that 26 times 7 is equal to 14 times 3, or 14 times, not 3, 13. I already figured out that those are two that are equal just by testing it out. So we now have negative 7 row 2 plus 13 row 3. And now let's go ahead and I'm going to bring it up over here. So that way it's not in the glare light that's right there. Is there a glare light? Yes, there is. So now that I'm going to bring it up here, let's do this. So we have negative 7 times row 2. We know that all the others are going to stay constant. And then we're only changing that third row, so everything else will stay constant. So this one's 0, this one's 0, because that's going to be our aim. We don't even need to do it because we know that that will work. Well, I know that will work. And then now we get to solve for the more complicated ones. Negative 7 row 2 plus 13 row 3. And that will put us with negative 7 times 8 plus 13 is equal to negative 43. Why does that number look weird? I don't like how that number looks, but let's just give it a little bit and see if it'll all even out. And then we get negative 7 row 2 plus 13 row 3. Negative 7, negative 28 plus 13, negative 13. Please work. 27. Why? Why do you not work? That shouldn't be what it is. That shouldn't be. Why are you 43? Hold on. Let's try to swap what's positive and negative here and see if that will make somewhat of a difference on the numbers that I'm getting. So we have 7 times 8, which is 56 minus 13. 56 minus 13 is 56 minus 13 is 43. Why are you 43? Why aren't you working? Negative 2 times negative 1 is 2, plus 3 is 5. Ah, see? there's so many little things on this one, so many tedious, tiny things that could go wrong. And that's why you just have to be incredibly careful with it. Because I guarantee all the other attempts that I've done at this have gone wrong because of something tiny and dumb like that. So now we have -9, which does actually seem like the number, and then times 7, 7 times -28 minus 13 times -13 is -27. Oh my god, it worked. Oh my god. Okay, so now we can, because our row echelon form 4 is optional, I'm going to kind of do it because I'm going to show you one step that you can do that would actually be helpful in this instance, and that would be hitting this all with a -1/9 row 3. So then instead we would have 3, 4, -1, 0, -26, 8, 8, -28, and then if I hit it with a -1/9, we have 0, 0, 1, and then now we have this one is 3. So if we were then to play the thing that we did over here, we could then put this all back into our system form. Our system form of that there would then be 3x plus 4y minus z is equal to 8. We would then also have -26y plus 8z is equal to -28. Then we would also have z is equal to 3. So now we have our system. So of course, this is going to be part of our answer. So that is going to be part of our answer. We're going to have z is equal to 3. And then now let's substitute that into the second equation, because that will leave us with only one variable. -26y plus 8 times 3 is 24 is equal to 28. We have 28 minus 24 is 4 divided by -26. Why are you big? Why are you big? Oh, because I didn't carry down the negative. Oh my god, I was about to have a heart attack. -28 minus 24, -52 divided by 26 is 2. Y is equal to 2. Now we have y equal to 2. Substitute in for that final one, because that's the only one that has the last variable we're looking for. 3x plus 4 times 2 minus 3 is equal to 8. So these two 8's cancel out. 3x is equal to 3. X is equal to 1. Oh my god, we did it. Now, you can go back and verify that this all works by plugging these 3 into our initial equations. So if we were to do that, we would see 3 plus 8 minus 3 is equal to 8. Perfect, because the 2, 3, and then minus 3 cancel out. 8 is equal to 8. That's perfect. And then we would go through and find that all the rest of them will even out. So if we were to write our answer for this, we would write it in coordinate form, because we're not going to say x equals 1, y equals 2, and z equals 3. We're going to write in coordinate form, and we're going to do it in coordinate form in alphabetical order. So x, comma, y, comma, z. This is our answer. Oh my god, I didn't mess up.